All right, so today we're going to talk about arithmetic sequences, or some people call them arithmetic sequences. I actually like saying arithmetic. Sometimes I get a little tongue-tied saying arithmetic. So whatever, arithmetic, arithmetic, but either way spelled the same way, but they are sequences, okay? So first off, let's talk about what is a sequence. So a sequence is a list of numbers, okay? So it's a list of numbers, which they're going to call terms. Okay? So the first number is called the first term, and the second number is called the second term, and the third number is called the third term. Okay? So here's an example of a sequence. So 1, 4. This doesn't need to be any type of specific sequence. It's just a sequence of numbers. Okay? It's a list of numbers. So that's a sequence. Now, certain sequences have patterns. There's geometric sequences, there's arithmetic sequences, there's some sequences that don't have any pattern, so we just call them a sequence. Okay? So what I just wrote up here actually has no pattern. You don't always add the same number, you don't always multiply the same number. It's just a bunch of numbers listed out. Okay? So it's just a sequence. So what makes a sequence or what makes something an arithmetic sequence or an arithmetic sequence? It's a pattern, okay? So a pattern that involves adding or subtracting consistently, okay? We call that a common difference, and I know it sounds kind of weird to say common difference, but it can be addition. But that's what it's called. Okay, so we're going to call it, this is called the common difference. And they're going to use the letter D for it. Okay, so I'm going to highlight this, the common difference. And it's going to be a lowercase d. All right, so whenever you see the letter D in an equation, that's a common difference. There's going to be another sequence called the geometric sequence, and that one they're going to call it the common ratio, and that's going to be denoted by the letter R. Okay, so it's not going to always be the same letter. So an arithmetic sequence is considered an arithmetic sequence because the sequence itself, the list of numbers, changes by a consistent addition or subtraction of the same number. So you might just keep adding 2 plus 2 plus 2 plus 2 over and over again to get the next set of numbers, or maybe you'll be subtracting 10 minus 10 minus 10 minus 10 over and over again, and that tells you that it's an arithmetic sequence, because when you look at the numbers jumping from one to the next, it's either always adding the same number or subtracting the same number. Okay, so that's what makes something an arithmetic sequence. Now, the next thing, and on your homework, I'm kind of mad at myself for not fixing this. I remember last year when we did these worksheets, we said, are the following sequences arithmetic, geometric, or neither? And then we realized later, well, we didn't even teach geometric yet, so why are we asking that? So on your homework, I'll remind you right now when I pass it out that the main question you're going to ask yourself is, are these arithmetic sequences, yes or no? Okay, so you don't have to worry about geometric, etc. So here we go. So let's go with the first one right here. 2, 4, 8, 16, 32. Okay, would you say that 2, 4, 8, 16, 32 either adds or subtracts the same number consistently? So from 2 to 4, what is it adding? Plus 2. What about from 4 to 8? So hold on, and then 8 to 16? Is it always adding the same number? No, it's adding 2, then a 4, then an 8, then a 16. So that's not an arithmetic sequence. An arithmetic sequence should be like plus 2, plus 2, plus 2, plus 2, or plus 8, plus 8, plus 8, or minus 7, minus 7, minus 7, right? Always the same number. So this is going to be no. All right, well, what about part B? We got negative 19, negative 13, negative 7, negative 1, positive 5. So what happens from negative 19 to negative 13? What did they do? They added 6, okay. What about from negative 13 to negative 7? Okay, added 6. Just because it happens twice, don't celebrate and say, yes, it is, right? You got to check them all. So negative 7 to negative 1 is also adding 6. From negative 1 to 5 is also adding 6. So did they add the same exact value every single time? Yeah. They could also subtract the same exact value. Again, this doesn't always have to be addition. So I'm going to write yes. And then what I'm going to do, just for the sake of doing this, I'm going to write the common difference. The common difference is a positive 6. If it was minus 6, minus 6, minus 6, then I put d equals negative 6. Okay? So it's pretty easy, right? Just kind of look at the numbers and ask yourself, from this one to this one, what happened? From this one to this one, what happened? As long as the same thing occurs every single time, then you're good. Okay? So, all right. So I'm going to give you a little bit of time to copy this. I'm going to pause the video just to give you like a minute or two. All right, so given the first term and the common difference of an arithmetic sequence, find the first 5 terms. Now remember, they gave us for part A sub 1, which means the first term, okay? We got to figure out A sub 2, A sub 3, A sub 4, A sub 5, meaning the first, the second, the third, the fourth, and the fifth term, okay? They did give us the D value, which tells you by what it's changing, right? So they're subtracting 2 over and over again. So I'm going to just kind of do this really quick. You don't have to, but this is just a habit that I developed when I was learning this stuff, so that I know that my goal was to fill in 5 numbers, right? Now, my first term is 3. So what do I do to the 3 to find the next term? Subtract 2. So 3 minus 2 is 1. 1 minus 2, negative 1. Negative 1 minus 2, negative 3. And negative 3 minus 2 is negative 5. Okay, and there you go. You got your first 5 terms. You don't have to do the stuff I'm doing in green. This is just to kind of show in notes, right? We subtracted 2 every single time. Okay? That's basically what happened. That's pretty easy, right? What about this next one? First term is negative 11, and D is a positive 6. So they want 5 total terms. So I'm going to write down 1, 2, 3, 4, 5. And I get to start with negative 11, right? That's my first term, negative 11. Okay? So every single number that I'm going to write to the right side is going to be added by 6. Okay? So negative 11 plus 6, that's negative 5. Negative 5 plus 6, that's 1. 1 plus 6, 7. 7 plus 6, 13. So we're just going to keep doing whatever the D value is. Just keep applying it to every number that you write down. That way you create the sequence that has that pattern, right? So from negative 11 to negative 5 to 1 to 7 to 13, they're all positive 6 units away from each other, okay? So that's how I know this is an arithmetic sequence, okay? They always have a pattern in between. Now there's going to be one question, just by the way. If I were to tell you this, it's just a side note. If I were to tell you that the second term is 10 and D is 5, and I want you to write the first 5 terms. 5 terms here. 1, 2, 3, 4, 5. If I told you write the first 5 terms, but I'm giving you not the first one, but the second one, that means this one is 10. What's the next number to the right of 10? 15. And then after? And then? Well, what's to the left? 5. What did you do to go left? We did the opposite, right? D says positive 5, but to go to the left, you're going to go negative 5. Okay, so this would be a 5 there. You're going to have 2 questions like that on your homework, where they're going to start you off in a different location, and then they're going to say, okay, you know what the common difference is, so you're going to do that, but then you might have to find a couple numbers to the left side, so you may have to add or subtract depending on what the D value is. Okay, so that's just a little extra thing. So here they're going to say, okay, we got 2 numbers that we're going to give you, okay, 35 and 51. I need you to find the numbers in between, okay? Now notice they don't tell you what the first term is because 35 isn't necessarily the first term. You see those 3 little dots to the left side? That means that there's more terms that way, okay? And 51 is not the last term because you can see that there's some little dots on the right side of 51, so that means there's more numbers to the right, okay? But they did give you just 2 terms. So the way you figure out the common difference, because you got to figure out the common difference so then you can add it or subtract it to get to 51. You're going to have to figure out what your common difference is. So here's how you're going to do it. All right. You're going to get 51 and you're going to subtract 35. Okay. So 51 and you're going to subtract 35. I think these are going to work. We'll see. So what do we get here? 16, right? 16. Now, how many terms to go from 35 to 51? Let's see. 1 term, 2 terms, 3 terms, 4 terms. It's going to require me 4 addition or subtractions to get to 51, right? 4 of them. So I'm going to say, okay, 16 divided by 4. Well, that answer is 4. That's your D value. Okay? So how do you find your common difference? You're going to get the 2 numbers they give you. You're going to subtract them. Okay? Be careful if the number on the left is negative, then remember subtracting a negative actually means adding, right? But just pay attention to the numbers they give you. But you're going to get the 2 numbers, you're going to subtract big minus small. Whatever your answer is, divide it by the number of terms it takes to get to the last term. So for us, it took 4 different arrows, right? From 35 to 51, I have to draw 4 arrows. So that's the number you're going to divide your sum by. You're going to get this, and you're going to divide it by this number. The answer, once you divide it, is your D value. Okay? If it's negative, that means you'll subtract. If it's positive, that means you'll add. Okay? So, it's positive, so I'm going to add. So, 35 plus 4 is 39. 39 plus 4 is 43. 43 plus 4 is 47. And the way you check if you got it right is you do it one more time. 47 plus 4, that is 51. So by adding 4, I was able to get to 51 consistently, right? Like adding 4 consistently. So that's how you're going to do these problems. If they give you gaps in between, you're going to get the first number and the second number. You're going to subtract them. Okay, remember, big minus small. And then you're going to count how many terms it takes to get to the last number, starting from the first one. Now, don't count the first one. Start from there. So don't say like 35 is 1. No, you're going to go over the first empty space is 1. The next empty space is 2. And if there's 5 spaces, 6 spaces, 3 spaces, whatever number of spaces, that's what you're going to divide by. Okay? So I can maybe just put that right here. It is a number of additions or subtractions to get to 51. Okay? That's the number of additions or subtractions that I'm going to need to do to get to 51. Are we okay with that one? If you have any issues with it on the homework, just ask, and I'll go help you. But they're not too bad. Just remember, Subtract the numbers, count how many times you have to move over, divide by that number, whatever that answer is, that's your D value. Okay? So here's the last thing. Arithmetic sequences do have a formula we call the explicit formula. Okay, there's an explicit and there's a recursive. I don't know if we're going to do the recursive one, but we're going to definitely do the explicit. The explicit formula is a way that we can write these sequences in a formula so that you can find any term you want, right? So if I were to tell you, well, here's a sequence 2, 4, 6, 8, and you're like, oh, that's an arithmetic sequence because you're just adding 2, so that's arithmetic sequence. And then I say, okay, what's the 946th term? You're going to say, well, wait a minute. I only know 2, 4, 6, 8, right? And you want me to find, I only know like the first 4. You want me to find the 900th whatever term? If you have a formula, it's easy to do. If you don't have a formula, then that means you're going to have to write it out by hand, and you don't want to write out 940 something terms, right? So a formula is helpful to find those terms that are way out, okay? So a sub n equals to a sub 1 plus n minus 1 times d. N is the term you want, so a sub n would be the nth term. If you wrote a sub 10, that means you want the 10th term. If you wrote a sub 46, you want the 46th term, okay? So n is a term you want. A sub 1 is the first term. D is the common difference. Okay? So that's the formula that we're going to use to represent these things. So I got 2 more examples. Example 4, A and B, and then we're done. Find the explicit formula for that arithmetic sequence. Now this one is very easy. The next one you might have to do a little bit of work. It's not terrible, but it's just a little bit of work. Because once you know your first term and your common difference, writing your formula is simple. So I'm going to rewrite it, just the main formula, so you guys see it. Okay? All I need to figure out is a sub 1 and d, and that's exactly what I gave you. So I'm just going to write a sub n is equal to 2 plus n minus 1 times 6. And that's it. That's the explicit formula. At this point, if you want the 100th term, you're just going to let n equal to 100, plug it in, and solve on the right side. Okay? So you'll do 99 times 6 plus 2. That'll be your 100th term. Okay? You don't have to write out 100 terms. So that one's pretty easy. But again, the reason why it's simple is because they gave you the first term and the common difference. For the next problem, did they give us the first term? Did they give me a sub 1? Now, I know you're looking at it and saying, well, no, because I don't see a sub 1 equals to anything. But remember, a sub 1 means the first term. Do you see a number that signifies the first term? Which one? The negative 38. How do I know that's the first term, not the 20th term? Well, they didn't put any extra dots in the front of it. That means that there's nothing to the left of it. So that is my first term. So I'm going to say a sub 1 is negative 38. Okay? Could I figure out my common difference? To go from negative 38 to negative 138 to negative 238 to negative 338, what did they do? How much is it changing by? 100, but in a positive or negative direction? Negative, so my common difference is negative 100. Now, if you're like, well, I don't know how to figure that out. Again, you guys have calculators, but if you're not sure, just do negative 138 minus negative 38. That's 100. If you do negative 238 minus negative 138, that's negative 100, not positive. This will also be negative 100, right? So if you just kind of take these two numbers and subtract them, or these two numbers and subtract them, or these two numbers and subtract them, you can figure out your common difference like that. And you can use your calculator, that's fine. But now that I have my a sub 1 and my d value, then a sub n is equal to negative 38 plus n minus 1 times, I'm going to put the negative 100 in a parenthesis so it doesn't look like I'm subtracting it, okay? So there's your explicit formula. And this is what your homework is going to be like. Okay? So just basically finding out patterns, writing out explicit formulas or filling in blanks, that type of stuff. Anybody have any questions on examples 1 through 4, definitions or anything like that? All right, so I'll go ahead and stop it here. I'll give you guys the assignment.